Finally, we look at the main problem, how to triangulate a general polygon. So the input is a simple polygon of size n, and we want to have a triangulation of P either through the list or a double connected edge list. The main strategy that we want to do here is to decompose it into a bunch of Y monotone polygons. And from the previous video, we know that we already can handle Y monotone polygons. So what does it mean to triangulate, to partition a polygon into Y monotone polygons? To be able to understand that, we need to look at the components of a general simple polygon. Okay. So a simple polygon could have a number of top vertices, and what these top vertices mean is that a vertex is a top vertex if both of its neighbors are below, right? So like this one, and the interior of the polygon is in between them, like this, or in other words, the angle is less than 180. So both of these are top. Similarly, you have bottom vertices, both neighbors are above and the angle is less than 180. So this is a split vertex. So this is in some sense it's similar to a top vertex. You can see that both of its neighbors going down, but the interior of the polygon is over here, which means that the angle over here is more than 180. So therefore it's called a split vertex. The sort of the opposite of this is a merge vertex, where both neighbors are up, similar to bottom vertex, but the interior of the polygon is between them, so the angle is more than 180 degrees. And then all the other vertices are normal vertices, like this one, which means that one neighbor is up, the other neighbor is down, and that makes it a normal vertex. So these two vertices are new, and it's a new thing that the top and bottom vertices are not unique. You could have multiple top or bottom vertices. So therefore, to decompose a simple polygon into a bunch of monotone polygons, we need to get rid of split and merge vertices. And the idea is to connect them, for example, to something that is above or below it. So for example, something like this. Okay. So now if I make this connection, then I have a Y monotone polygon like this. So there is only one top vertex, and now there's a chain that goes all the way down, and a chain goes all the way down like this. So that's a Y monotone polygon. That's one. You have a Y monotone polygon that's just a triangle, and of a Y monotone polygon that looks like this. Okay. So by just getting rid of split and merge vertices, we can decompose the point into a number of Y monotone polygons. And the way you want to get rid of them is that you take, say this is split one, you connect it to something above, and you take this one, connect to something above, and then we're done. So the main question is, how do we get rid of them, right? We need an algorithm to get rid of the split and merge vertices. So in the book, they have an algorithm that does both of them at the same time, but I can actually show you something a bit easier to understand, even though a bit more expensive to implement. And our idea is that the split and the merge vertex are essentially the same if you turn the polygon around or flip it vertically. So it's just sufficient to get rid of one of them, right? Let me go back to this picture here. So this vertex is the same as this vertex if I just flip this 180 upside, or flip it upside down. Okay. So in other words, if I know how to get rid of these vertices, if I flip the picture around, I will know how to get rid of these vertices. So it's sufficient just to get rid of one of them. And that's what we're going to look at next. And the basic idea is a sweep line. And I'm going to show you the details of the sweep line in the next.